All right, we're back, and we didn't leave. In fact, would you believe? We've got some questions here to answer. The first one, and you're all welcome to jump in. Will it ever be possible to forecast whether a drought will occur in a year or two in advance?
So that's a very interesting question. It's a very hard, actually, to answer that. But one thing that I can say about it is that we do have the capability to forecast modes of variability in a year in advance. So when El Niños and La Niñas are happening a year in advance, it's really hard to know when a drought will start. But if, let's say, a drought is already happening in a certain area that is affected by those modes, and if let's say an El Nino is happening or a La Nina is happening and bringing rain, then we can know more or less what is going to happen. What it's a tendency to either break the drought or exacerbate the drought that is already happening.
So you can say, look, we're in a drought and it's not looking good for that to be broken in the next year. Or, you know, we potentially will have a higher likelihood of it being broken if, you know, with the switch, the ENSO switch happens that we're predicting in the next year. Great.
Can I add to sorry, I'll add to that in that we actually, so predicting sort of like a year or 2 years, actually what we're going to see in that year is very difficult. But we can say with sort of more confidence what sort of the trends are that we expect in the future. So which parts of the country do we expect to become more drought prone? And that's, not saying it's going to be a drought in this particular year, but you can expect to be in drought conditions more often in some parts of the country.
Yeah.
I'll take the optimistic view here, and I'll say yes, we will at some stage be able to do this. If you look back over the last few decades, the knowledge we've gained over these key processes and mechanisms and climate modes, and our ability to predict these things over the last 20 years has clearly got a lot better. It might take another 20 years before we can do this, but I think we'll get there.
Yeah, well, I noticed in the latest IPCC report, there's a lot more things being said with a lot more confidence, and obviously that goes with a lot more stark evidence as climate change progresses, but also with the changing and improvement of modelling and things like that. Question 2, is there a link between droughts and intense bushfires like those we saw in the Black Summer of 2019-2020 here in Australia? Or as I like to call it, the black spring summer, because it was both seasons.
It started early, yeah.
Yeah, I'm happy to start on that one. And certainly in the Black Summer, the drought in Eastern Australia was a factor. So one of the factors that you need for droughts to for bushfires to become large and extreme is a dry fuel load. And so the drought that we'd seen in Eastern Australia that started in about 2017 and ran through into that 2019-2020 summer had sort of set the wheels in motion for the fuel being really dry. So then when we had those hot and dry conditions, we also had an alignment of the ocean variability as well, particularly in the Indian Ocean, with a really strong positive Indian Ocean dipole event that contributed to the dry conditions leading into that fire season. All those conditions came together to set us up for a really bad fire season that summer.
Yeah, I'll add to that. The dryness of the fuel is key for any fire at any time, and you probably only need a seasonal drought to dry the fuel out enough to have a fire of some sort.
Mm-hmm.
But once you have a drought that lasts several years, that means you're not just drying out the leaves or the litter on the ground. You're drying out parts of branches and larger fuel elements in the system. And having a fire, once you've dried out these large elements, this is when you can get really large, dangerous, extreme fires being fueled by those large dry fuel elements.
Yeah, I've got a question leading on from this. This one actually comes from Andrew Watkins. Hi, Andrew. Great to have you watching. Who asks, and some of this we've mentioned, droughts are now often lead to large fires, Black Summer, Black Saturday. Do you think this is because we swing from very wet and grow more vegetation and fuels to very dry? Obviously, you've touched on some of this. And why do you think these swings have been happening with only short periods of neutral and benign? I suppose this goes in some way to ENSO. Anyone want to tackle those questions?
Yeah, maybe I can answer that. So ENSO is a natural phenomenon, right? So it occurs from 3 to 7 years in our climate system. So what we've seen in the historical record is that there was a tendency in the present, like in the recent years, to have more Central Pacific El Niños that have an impact on Eastern Australia. But I'm actually not sure if this swings, that is, like wet and dry periods, has become like more frequent in past years, actually. So there is a change that we've observed a change towards a Central Pacific El Niños, and that has an impact for Eastern Australia, but not necessarily like a strong swings related to ENSO.
I'll add to that. So the first part of the question, I guess, is yes. You need to have fuel there. So if you have a wet period and you grow the vegetation really well, that means you have a lot of fuel. And then if you have a dry period and you dry that fuel out, now you've got a lot of fuel, not just vegetation. Now you've got a lot of fuel for your fire.
Mm-hmm.
So it's that cycle that really does help Australia be a land of fire. And this is why a lot of our native vegetation, a lot of our eucalypts and stuff are very well adapted to the fire. It's been like this for a long time.
Yeah.
Now, as I mentioned earlier, with the climate change, as the globe's warmed, we have seen an increase in evaporation rates. So if you have a cycle, a wet dry cycle, like Andrea was just talking about, even without a major change in that cycle, if you're evaporating more during the cycle, that means you enter that dry phase faster, and you can get drier more frequently. So we have this wet dry cycle. If anything, we're getting into our dry part of that phase faster on the land. It's drying out faster because of the evaporation, and that means it is primed to burn more readily.
Yeah, and I suppose we also have to talk about wind, because whilst wind might not necessarily increase fuel when it comes to all of the dry vegetation on the ground, it does prevent burning off, at different times of year when we've potentially done fuel reduction burns. Are we seeing those sorts of conditions reduced?
Yeah, I think that's an interesting question. And particularly, I mean, winds are a really important part when we actually have fires as well, in terms of allowing fires to spread faster and become quite dangerous. There's a little bit of evidence suggesting that in a warmer climate, we may have more of that frontal activity across southern Australia, so potentially increasing our fire risk. But it's fairly sort of uncertain. And one of the reasons is whether our climate models can actually capture those frontal processes in a good enough way. And so that's one of the areas where looking to how we take this research forward is looking at how can we get those weather scale processes in our sort of large scale climate models, so we can start to reduce the uncertainty as to how those processes are going to change in the future.
Yeah, and we've had some great discussions previously with ARC, Centre of Climate Extremes researchers, on the need for more research into improving climate modelling for those reasons. Obviously, we want to be able to know more and with more certainty on every factor.
I could just
Yeah,
add
sorry,
something
Jason.
to this conversation, Lee. So if we're thinking about conditions that are suitable to do prescribed burning, we've looked directly into this, and we've already seen that the usual windows that we use in eastern and southern Australia, which is usually in the sort of May or October, November time period to do this prescribed burning, the days where you have suitable conditions have been decreasing in the last several decades in those windows. And it looks like with climate change, that's going to continue to be the case. They'll further decrease in those windows. So, which means there's less opportunity to do this kind of prescribed burning in those times, which is probably not good news. But by the same token, that through the winter months, you start to see more and more periods where you have those same conditions that we would burn in today. They start occurring more in the winter. So it could really just be a matter of changing the management here so that more prescribed burning is happening through winter months rather than being restricted just to the spring and the autumn.
Yeah, absolutely. There's so many different things for policymakers and decision makers to take into account when, when we're thinking about what we can do as humans. And definitely, if you're in the business of fighting and fire reduction through prescribed burning, then that's something to think about. Or whether we need more staffing for controlled burns so we can do more controlled burns on the days when it's possible. I don't know. Maybe that's a bad idea. Just spitballing some ideas.
Well, in a lot of states of Australia, it's done by a lot of volunteers, these prescribed burns. So
yes.
staffing is always a question there.
Staffing is always a question. Shout out to anyone who's a volunteer firefighter. I know my parents are in the volunteer brigade back home. But yes, we have had a lot of discussions around the idea that tackling a lot of these issues means we need people on the ground who are able to help. I'm just checking. We've got one more question from Andrew before we wrap up. No, he just says, oh, yes, thanks for your answer. That was great. How confident are you in projections for changes in the Indian Ocean dipole towards more positive events, such as the one before the Black Summer? He asked. I think that's one for you, Andrea.
Yeah, so the projections tells the models, most of the models tells us that the Indian Ocean will change towards a positive Indian Ocean dipole, so positive Indian Ocean dipole-like pattern. And that pattern generally is associated with drier conditions for the southern parts of Australia and the southeast. The episode that we had in 2019 was a really unusual episode. It was super extreme Indian Ocean dipole. And that happened, this episode didn't actually co-occur with ENSO. So generally in our historical record, we see a lot of these Indian Ocean dipoles co-occurring with ENSO. And that's why it's so complicated to understand the impacts over Australia, because they combine, and their combined effect tends to be exacerbated in Australia. Mm-hmm. So these interactions are quite complicated. So the projections tends to tell us that will be towards a positive Indian Ocean dipole, and there are studies showing that Indian Ocean dipole will become more frequent in the future as well, and extreme El Niños more frequent in the future. So this certainly will have an impact for Australian rainfall.
Yeah, and Nerily, we were talking about the future just there with Andrea, but what about the past? I know you've done some research into IOD, or Indian Ocean dipole, going back into the past.
Yeah, and this is a really nice example where if we bring together a whole range of evidence, we can start to say things more confidently than if we just look at the climate models for the future. We know that there's some things that the climate models we're not confident that they get the Indian Ocean dipole exactly sort of as it actually occurs. But when we combine it with looking at our observational record, where in the observational record it appears that these events are becoming more common and they're becoming stronger. And then we can also couple that with paleoclimate data, and we can go back many hundreds of years using coral records from the tropical Indian Ocean. And that really helps to cement this concept that we are seeing a change in the way the Indian Ocean dipole operates. These positive events, like the one that we saw in 2019, they're becoming more common. It's more common for these events to be very strong. But again, we get this warning when we look at paleoclimate evidence that it's actually possible for these events to be even stronger than that 2019 event. So just with natural variability, the Indian Ocean can do even more than what we've seen in the last 100 years or so.
Wow. Well, thank you all for this. It's been a really enlightening discussion, and I could talk your ears off for hours, but I do have to let you go so that you can go about your business of answering some of these big questions that we're asking you. I appreciate your time. Thanks again to everyone who's been watching. We've been streaming on Simpatico TV, which is the home of Climate Australia, and also to those of you who've been watching on Facebook and YouTube, thank you very much. Where can people find out more? The CLEX website is great. Do you recommend anywhere else that people go to find out a bit more about drought or your work?
The CLEX website would be the first place to find us and get further links to the work that we're doing personally. Mm-hmm. I'd say, obviously, we've just recently had the new IPCC report come out, so anyone who would like to find out more about what's being projected for the future and more about the processes themselves and how they work, they do have quite a nice sort of summaries in that report and some nice figures that sort of give a good guide to how the processes all work together and interact. So I'd recommend checking that out as well.
Great, thank you. Awesome. Well, thanks to you all, and thanks to everyone for watching. And that's it from us. So goodbye.
Thanks very much.
Thank you.